Okay, so one way to approach these questions is to just draw yourself a sketch of the situation, right? So remember when we're talking about limits, what is inside of the limit, okay, is nothing but just a function. Okay, and you can see over here we've got the function 4 over x, and over here we've got the function minus 2 over x. Both of these are hyperbolas. Okay, so you can draw yourself a quick sketch of the two functions. Okay, just reminding yourself that these two hyperbolas are basically just the mother hyperbolas that have a vertical asymptote as the y-axis. Okay, so their vertical asymptotes is the y-axis, and their horizontal asymptotes is the x-axis. Okay, so these two functions will never cross the y-axis, and they will also never cross the x-axis. Okay, so let's start with the first one, right? With the first one, what they're asking you is to find what is the limit as x approaches 0 of 4 over x. Okay, so in plain English, what this is saying is, what is this function approaching? Okay, so what function value, f of x, is this function approaching as you are approaching x is equals to 0? Okay, and this is actually in two parts. You're actually thinking about approaching x from the right hand side. You will see it sometimes written with a plus sign over there. And you're also thinking about what happens when you're approaching 0 from the left hand side. Okay, and these two limits have to be equals to each other in order for you to have an overall limit of x approaching 0. Okay, so let's see what happens with this specific function. Okay, so with 4 over x, okay, as you approach 0 from the right hand side, okay, then the function is approaching positive infinity, right? And as you approach 0 from the left hand side, okay, then the function is approaching a negative infinity. Okay, so now you can see that the left hand limit and the right hand limit, so the values that we're approaching from either side, are not equal to each other, so there's no specific point that this limit is approaching. So when that happens, what we say is that this limit does not exist. Okay, so this one okay, so this limit does not exist. Okay, notice that when we're talking about limits, we don't say that it's undefined, we say that it does not exist. Okay, and you can abbreviate this by writing DNE. Okay, it does not exist. Right, let's look at the second one. Okay, so with this second one, what they're asking is, what is the limit as x approaches positive infinity, okay, of the function negative 2 divided by x. Okay, so we've got the sketch of the function of negative 2 divided by x over here, right? And what we are going to be doing is we are going to be seeing what happens as we go to, this one is only basically one-sided. You just want to know what happens to the function value as you go to very big positive numbers. Okay, so as you go to the right on the positive x-axis, okay, and you see that the function basically just approaches 0. Okay, so the function just goes and tends towards this horizontal asymptote. Okay, so this limit is equals to 0. Another way to think about this one is just to think about plugging in very big x values, and you know that with a fraction, as the denominator gets very big, if the numerator is staying constant, then the whole fraction will just go to 0. Okay.